Here we are in part 4 of my astrobiology series entitled Are We Alone in the Universe? So again, I'm Mitch Campbell and we're learning all about astrobiology, at least an introduction to it. So in part 4, we're going to talk about where we're looking for life. And in this case, we're going to be looking at our own neighborhood. So we're going to sort of start close to us before we move out. So we're going to start with the inner solar system, in other words, our little neighborhood, and we're going to go to the outer solar system as well. So we'll talk about where we've been and what the search has given us so far, and actually where the interesting places are. So just to remind you again, remember what we're looking for? We did this in previous videos, where we're looking for these 4 main things: organic building blocks for life, and those are likely, those are needed by life, and those are likely everywhere. And then we need energy sources, so the sun, for example, but it could also be some other chemical source or maybe even gravitational forces in some way. And those are also likely needed by life. And then liquid medium, so we think that we need liquid water. So liquid H2O, we need it to be liquid, so liquid water. We likely, now oxygen is one that we might look for. This is one that's actually created by life. So if we find atmospheres that have oxygen in them, that'll be really exciting. But just to explain here, the main one we're actually looking for here, we're starting off sort of nice and straightforward, because we think these are most places. There's not many other places in our solar system with oxygen, so sadly that one's out pretty fast. But this one right here, liquid medium, that's mainly what we're looking for here. We're going to follow the water. So that's really what we're trying to look for, is where could there be liquid water? Or where could there have been liquid water in the past? Because maybe then there was life. So that's sort of our main driving force here, is we're trying to follow it. Now, in our own solar system, the good news is we can actually go there and check it out. I mean, we can go send robots there and go take a look if we really want to. Now, even if life isn't alive there now, so let's say we find some sort of evidence of past life somewhere else, even a fossil would be a huge discovery. That would be a piece of bones that have actually turned to rock. So if we found fossils, for example, that would be a huge discovery, because that would prove that life can be elsewhere. And so that would really, really have a big effect. I know you may not think it's very exciting that if we, are we going to find little aliens crawling around? It sadly doesn't seem so likely, at least not easily found. But I'm going to show you where we are looking and what the results are and where life still might be hiding from us. So we're going to mainly be focusing on our own solar system. So let's start on a little tour here. So our own solar system, solar means sun. So we're going to look at the system that's around our sun. So this is our star. Now this diagram right here is not to scale at all. It's just to show the order that things come in. So we have the sun, and I like how this picture was taken in a different filter. It almost looks like it's smiling, doesn't it? Doesn't it almost look like the sun is sort of smiling here like this? Sort of looks like it's smiling at us. And we're going to do a short little tour from sort of inner to outer. So we're going to consider the inner solar system is going to be Mercury to Mars. So Mercury, Venus, Earth, Mars. And after that, the outer solar system is Jupiter all the way out to Neptune. Pluto isn't counted as a planet anymore, but it still is an interesting place. It has its own little moon, and I suppose there could be something there. But the further out we go, we think the less likely there is to have life there. So we're mainly going to focus our efforts on the inner solar system and the outer solar system. This is sort of the differentiation here between the two. We're going to sort of split them up like this. Now, I'm going to skip Earth because, we know that there's life on Earth. That's great. So we're going to sort of skip this one. So we're going to talk about the rest of them. So away we go. Here we go. We're starting our little tour. So Mercury is the closest one to the sun. Now, Mercury, because it's very close, it's very, very hot. Now, what's really cool, this is a real picture of Mercury. I think it's a really cool picture. And it's taken pretty recently by a robot called Messenger that's orbiting around it. So it's currently in orbit right now, snapping lots of pictures. So it's so close to the sun, in fact, it's very hot. It's around 425 degrees Celsius, which is, I think it's really quite warm. Keep in mind there's also a dark side to it, so maybe that's actually, that'll be considerably colder. But on the hot side, it's around 425 degrees Celsius, so probably too hot to have life as we know it. It certainly couldn't have water. and that's because it's more than 100 degrees. Look at all the impact craters it's got. So that means lots of these events, where something actually came in, slammed in, and sort of made, lots of stuff eject outwards. There's been lots and lots of impacts. Look at them all. They're everywhere. And in fact, they're one on top of the other. So some of them have actually had an impact crater on top of another crater. I think it's really cool. Now, it has almost no atmosphere. It has a very slight little atmosphere, so it doesn't really have much gases around it, which means it probably doesn't have any oxygen, and that means, we don't think there's much life there. But this is there's a mission there called Messenger. Now, for each of these different places, I'm going to be mentioning the missions here. That doesn't mean it's the only missions that have been there. This is just, what I think are some of the more interesting ones, but there's certainly other missions that have been sent to these different places. So you're welcome to look up different space missions that have gone to these different places. I think it's really interesting to look up. But Messenger is one that NASA has going around right now. So that's Mercury. We don't think it's a good place to look for life as we know it. How about Venus? That's the next one out. Well, again, the temperature is super hot. It's 470 degrees Celsius. So that is crazy warm. So that's actually hot enough to melt lead. So we don't think it's a nice place for life as we know it. Now, what's interesting, though, it does have an atmosphere. So it does have gases around it. This picture, for example, notice you can't see craters and things. It's because it's covered with this really thick, extremely hot atmosphere. Now, it has a really high atmospheric pressure, and this is what I want to talk about here, 90 atmospheres. I want to talk a little bit about what pressure is. I mean, on Earth, for example, we're feeling what we consider 1 atmosphere of pressure, ATM for short, for atmosphere. Now, we call it this because that's what we have on Earth. So what's happening is the atmosphere around us, the gases around us, are actually pushing on us. You may not feel it, but there is a pressure. It's pushing on you right now. And our bodies are well designed to handle this pressure. This feels perfectly normal to us. So this is sort of the push on our bodies. And yet this push can do many different things. If you've ever gone to really high altitude, then there's less pressure, so that means things act differently. So for example, at high altitude, I know the highest I've ever been is at 6,000 meters, and there you can really feel the difference. I mean, your breathing is really crazy, you don't feel very good, you have huge headaches, you're not hungry. It's not really that fun because your body doesn't like it. That's because your body's designed for 1 atmosphere. Now, what happens if you increase the pressure? So in other words, if you go more than 1 atmosphere, you've probably experienced this if you've ever been swimming. Have you ever been in a swimming pool, and as you dive down, you can feel that the sort of pressure on your ears increases? And that's because, as you go down in the water, there's more pressure. And just to explain this, this is 90 times what we feel here. And to give that sort of an equivalent, anybody who goes scuba diving, for example, you might have looked this up or learned about this, but around every 10 meters under the water, you increase the pressure by about 1 atmosphere. So this is equivalent, 90 atmospheres is roughly the equivalent of going down by around 1 whole kilometer under the water. So can you imagine the pressure on you at 1 kilometer under the water? That's the pressure that you would feel if you're standing on the surface of Venus. So crazy high pressure, probably not a good place to be. Now, besides the crushing atmosphere and searing pressure and temperature, it also has a high amount of sulfuric acid. So that's also really bad. This sort of stuff really melts through everything. So it's sort of, some people call it hell on Earth. What's interesting about its surface, though, on Venus is that it doesn't have many craters. So there's some sort of process that's actually renewing the surface and sort of erasing these craters, probably eroding it. We're not quite sure. Now, it has a greenhouse effect, and you might have heard about that on Earth here. A greenhouse effect is when the atmosphere traps the heat in. Okay, that's really what's going on here. That's when the atmosphere traps the heat in. So what happens then is that, if we have the greenhouse effect, that's what's happening here on Earth, and that's good. It keeps our atmosphere nice and warm. This is an example of the greenhouse effect gone crazy. This has gone sort of too far. It's so hot, in fact, it's like super burning. So you probably don't want to go there. Now, some people have said, could there have been life in the past there? Yeah, maybe. I mean, there could have had oceans in the past, but that would have been vaporized as the temperature rose. So as the temperature got higher and higher, as this greenhouse effect increases, it's very likely that if there was liquid water on there, it would have all vaporized and turned into gas. So we don't think there's any liquid water on there right now, and so we don't think that there's life there right now. But some of the missions that were sent there, interesting ones, are called Venera. These are Russian missions. They sent a whole bunch there. A lot of them sort of crash landed. But a few of them made it and landed and actually took pictures of the surface here. I just want to go back for a second, because my goal here is that when you look at these planets, maybe you look in the sky and you see a little dot, and you have a little app that tells you what that planet is, and maybe it tells you, oh, that's Mercury, or that's Venus. Venus is actually pretty bright in the sky, for example. Mercury is a little bit dimmer. It's a little bit harder to find. But what I want you to see, though, is that these planets, they're places, too. They're places where you could actually go to and visit and see. Some of these rocky ones, you could even stand on the surface of it. So I just want you to see that, I mean, they're places. They're not just dots in the sky. So take a look at these pictures here. This is taken from this Russian lander called Venera. There was a whole bunch of them that landed. But one of them, this is actually one of the pictures that it took. So it's amazing. We actually have a picture of the ground on Venus. So what happened is this. This Russian lander, it landed. The problem is its camera sort of was pointed a little bit too far down. It snapped a picture and then it promptly died. Because the landers don't live very long because of this insane pressure and sulfuric acid. So you can see the atmosphere here. It's taken with a very sort of bubble, a very wide lens, wide angle lens. So things look a little bit distorted here. But they had these things in here so they can tell what real colors they are. And I think it's really cool. You can see pieces from the robot here. It landed, took a picture, sent it to Earth, and then died. Now, what happened is this here is a guy named Don Mitchell. He took some of these pictures from these landers and stitched them together and sort of un-fisheye lens effect. So he sort of undid this effect here and to try to sort of straighten it out to look like this is what it would probably look like if you're the lander looking straight across. This is very likely the view you would have had. So he sort of used some photo manipulation to undistort the picture. But this is really what the surface would have looked like at this location where this particular lander landed. This is a different one than this one over here, by the way. You can see they're actually different ones. But I think it's really interesting, isn't it, that this is the surface of Venus. How cool. Now, there's another location, although I said we're not going to talk about the Earth, but we will actually talk about the moon. So what we call Earth's moon. So our own moon, we call it the moon. Other planets have other moons, and we have names for them. But our own moon, we just call it the moon. This is a picture of our moon here. Now, our own moon, it doesn't have an atmosphere, or at least extremely little. And as a result, there's really not likely to be life. There's also the temperature is not very nice for life at all. It's too cold in the dark and it's too hot in the sun, so it's not a likely place for life. But what's interesting, though, is it's the only place where humans have walked, other than the Earth, of course. So we've sent robots on other locations, but the only other place where humans have actually walked around is the moon. Now, some of the interesting missions, Apollo, those are the NASA missions where actually people walked on the moon. But there's other robotic ones like L-Cross and Chandrayaan, and those figured out some really interesting things, especially about water on the moon. Because it turns out that we know now that there is some water ice in craters. So in some of these craters, some of these big impacts, there's some of these big holes that have been sort of created by impacts again, sort of something hit and stuff went flying out. In some of these craters, there's actually water ice in them. So there's not liquid water, but there's water in ice form, which is actually pretty interesting. But I want to show you some beautiful pictures taken from the moon. So this is one of the pictures taken from Apollo. I think it might have been Apollo 8. I'm not 100% sure, but this looks like an Apollo 8 picture, just because that's one of the first ones where they actually orbited around the moon and then took pictures of it. They didn't actually land on the moon on Apollo 8, but they were going around just to go make sure that they can get to the moon and back, and just sort of orbit around the moon a few times and come back to Earth. So now we have a moonrise. This is actually called Earthrise. Isn't that a beautiful picture? You can see the Earth here, the sunny part, and over here is people who are at night, so they're sleeping likely over here. What a beautiful picture. So that was taken by this orbiter as it was orbiting around the moon. Look how close it was to the moon, actually. Now, they actually landed a whole bunch of landers. So on Apollo, Apollo 11 through, maybe I'll write this down here. This is actually really interesting. So Apollo 11 through 17, those are ones that actually landed on the moon itself, although there is one exception. So 11 through 17, except for, so I'll say not number 13. 13 didn't make it. It was actually a really interesting story. It's very useful to look this up because I think Apollo 13, there was a movie made about it, but I recommend you kind of look it up. It's really interesting. What happened was on their way to the moon, they had an accident and they lost a whole bunch of their air pressure and they weren't sure if they were even going to make it back. So it's a really interesting story, I think. But on Apollo 11 was the first one where they landed on the moon, and Apollo 17 is the last one. This picture right here was taken on Apollo 17. So this is on the last mission to the moon, and no humans have walked on the moon since then, which is a little bit sad, really. These are landings that were done from 1969 to 1972, so that's when they've actually done these landings. So that's a long time ago where they last landed. So on Apollo 17, for example, that one, they actually had a little buggy where they actually drove around. And on that one, I mean, they drove around a total of 35 kilometers on the moon's surface with this. And at their farthest from their little lander, like their spaceship where they landed, their farthest distance was 7 kilometers. How scary is that? Can you imagine being 7 kilometers away from your lander? So if you have a problem with your car, it's going to take you forever to walk back. You're probably going to die because you're going to run out of oxygen. So how interesting that they actually went there. So it's worth looking up some of these movies, for example, that are made about the Apollo landings. Like Apollo 13 was a really interesting one, how they actually made it back to Earth alive. So they didn't die on this one right here, but they didn't land on the moon for Apollo 13. But Apollo 11, 12, 14, 15, 16, 17, they all landed successfully and brought people back. There's even a BBC special called BBC, and I think it's called NASA Triumph and Tragedy. And that one is really worth looking up. There's also other good movies, of course, but I mean, these are really good ones that sort of explain a little bit about what happened with the Apollo landings. So those are some of the places in our inner solar system. And in the next video, we're going to talk all about Mars.